Inverse variation. Inverse variation is a relationship between two variables in which the product of the two variables is a constant. So the phrase y varies inversely with x, so that's our clue that we're talking about inverse variation, has the equation that takes on the form y is equal to k over x, or we could say that xy is equal to k, where k is a constant of variation. Note that inverse variation cannot be solved with a proportion. Okay, problem number 4. If y varies inversely as x, so I'm just going to stop right there. That statement, varies inversely, is telling me that right now we have y is equal to k over x. So, if y varies inversely as x, and y is equal to 6 when x is equal to 12, find y when x is equal to 9. So, we begin with this information right here. Y is 6 and x is 12. So, 6 is equal to k over 12. If we go forth and now solve for k, what we need to do is, if k is being divided by 12, to undo that division by 12, we can multiply both sides by 12 over 1. And we get that 72 is equal to k. Now, we can come over here and we can find y when x is equal to 9. So again, using our inverse variation equation, y is equal to k over x. Y is equal to 72 divided by 9. 72 divided by 9 is 8. So y is equal to 8. Okay, let's look at a word problem. The coaches of a youth baseball league estimate that 15 adult volunteers working 25 hours can repaint all the bleachers in time for the baseball season. The time spent working for each adult varies inversely with the number of volunteers. Find the total of work per person if there are 75 adult volunteers. All right. So the first thing that we need to do is we need to determine what kind of variation that we're talking about. And there it is, inverse variation. Y is equal to k over x. Now, this statement that I'm about to highlight, the time spent working for each adult varies inversely with the number of volunteers, tells us what units y and x will take on. The time spent working for each adult varies inversely. So time is equal to k over the total number of adults. So we're at number of adults. The time spent working varies inversely with the total number of adults. So, we begin with this first statement that says, the coaches of a youth baseball league estimate that 15 adult volunteers working 25 hours can repaint all the bleachers. So, according to our equation, we can say that 25 is equal to k over 15. Now, if we solve for k by multiplying both sides by 15. We get that 375 is equal to k. That is our constant of variation. Now, we want to find the total number of work time per person if there are 75 adult volunteers. So going back to our equation, time is equal to k over number of adults. We want to find time. Our constant of variation is 375, and we have a total of 75 adults. If we take 375 and divide it by 75, we get that t, or time, is equal to 5. So the answer to this problem is that find the total number of time per person. That's going to be 5 hours per person. So how do we solve these problems? Again, it begins by first of all identifying what kind of variation that we're dealing with. And then, once you decide that it's inverse, for this problem, that was inverse variation, we had to look at this statement to determine what units do y take on and what units do x take on. Y is our time, x is our adults. So once you have your inverse variation equation, we look at our initial statement, plug in our values for x and y, find k, and then we're going to use the same equation, but now we have a value for k, and we're going to find the missing value.